OpenAI actually found that demo, and they had been looking at building voice mode for a while. They decided to experiment with LiveKit and give it a try, and then they became fans of the platform. So I think the GPT-4o demo was this amazing moment. When I saw that demo, it was 40 years, to the year after Steve Jobs was on stage at the ends of college, demoing the Mac to the world for the first time.
Wow.
And the Mac said, hello, I am Macintosh. The crowd just cheers. And it's like, wow, we have a computer that can talk to us. And I think that's been the dream of sci-fi. This GPT-4o demo, in my opinion, was like the starting gun for that future we've been dreaming about for a very, very long time.
LiveKit's enabling it.
The camera and the microphone, I believe, will eventually replace the keyboard and the mouse. I still stand by that statement.
Welcome to Autopilot, a podcast where we discuss the past, present, and future of AI and automation.
From Atlanta, Fulton County. Passage.
That's one small step for man.
We explore how AI is creating and disrupting large industries in conversations with top founders, investors, and historians. I'm your host, Will Summerlin. Let's dive in.
Russ, thanks for joining us on the Autopilot podcast. So today we're going to get into the future of AI as it relates to audio and video, dissect some of the infrastructure challenges, specifically networking, talk about LiveKit, a company that you've built. But before we get into all that, let's start with you. Can you share your background, where you grew up, how you got into tech, and then we'll go from there?
Yeah, for sure. Thanks for having me, Will. I started my career, I grew up in Canada. That's where I was born. My dad was into computers, electronics. When he was a kid, got into like radios and electronics. He was an electrical engineer coming out of university in London. And when I was growing up, we were kind of one of the first kids on the block that had access to computers, period. This is in the early 80s. And so I grew up with computers and I had a few in my house, and they were all networked, and we were always playing, network games like Doom and things like that, having LAN parties at my house. And so I kind of grew up around electronics and computers and networking. And fast forward a little bit, my dad ended up taking a job in Silicon Valley in the 90s. He was working in semiconductors and startups in that space, kind of in the computer hardware space. And he ended up moving the whole family out after spending 2 years in Silicon Valley, kind of working for this startup and flying back and forth to Canada to see us. Moved the whole family out in 94. And then I think I just grew up in this area in Cupertino, surrounded by kind of the entire startup movement of that era, right? A lot of people working on hardware. The internet was still very new. The web was a very early thing at that moment, hadn't really exploded yet, but was just on the cusp. And so I think that my dad gave me a lot of exposure to technology. It took me to like CES. I think I was the youngest person at CES when I was like 14, going to this conference, this giant conference, and meeting people there. He used to take me to VC pitch events, which, we're still doing those things today. And so I used to go to those early ones back in the day. And so I just think I was steeping in Silicon Valley for most of my youth. I ended up having a friend who dropped out of college while I was at Davis. So I went to Davis, studied computer science, always wanted to build video games since I was a kind of a young kid. I was obsessed with video games and I always wanted to make my own, in the same vein as or in the shadow of John Carmack or John Romero. And so my friend had dropped out of college and, still kind of wanted to build a video game, but he ended up taking a job in Mountain View, and just 2 doors down was this small fund called Y Combinator that had just opened up a Mountain View office. And so he saw it open up, and he said he started to do some research and learned about Paul Graham and hackers and painters and all of that. And he decided to walk over one random day and chat with Y Combinator about what is it all about? How do we become a part of this? So he went there, he pinged me and he said, hey, it's not building video games, but how about we build a company, a website, and sell some software on the internet? we can go do this Y Combinator thing. And they fund kids out of school to go start companies instead of going and taking jobs somewhere. So this is, 2007, 2006. And so pretty early. It wasn't the normal path that people took at that time when you were in college, coming out of it and starting a company right away. And so we went to YC for a dinner there with the second batch and met a bunch of founders. And after that, decided to apply. We sent an application in to build a mobile social network that was going to run on dumb phones, right? This was before the iPhone even came out. And so something similar to Dodgeball, but with an actual application interface instead of just being based on SMS. And Paul sent us this message, which he said, well, there's this company that we funded called Looped. What are you going to do differently than Looped? And so we wrote this whole thing kind of explaining how it's, serving a different audience. And Paul responded, I still have the email I've looked up, but Paul responded, I don't think you can beat Sam. And so I think he was right about that. But yeah, so we got rejected our first time we applied. And then what was also happening at that time were these webcams were being built into the white plastic MacBooks. It was the first time really that there was a camera being built into a portable computer that you took around with you anywhere. And we saw the opportunity of using that kind of hardware, that technology embedded in those MacBooks to, allow you to instantly connect with anybody on the internet using video. Chat rooms were a thing with AOL and stuff like that and AIM. But using kind of these higher fidelity sensors like the microphone and the camera wasn't really being done yet. I was at Cisco doing a co-op during my master's. And at the time that we applied with this idea to YC, and we had just bought WebEx. And WebEx was kind of the application that was most popular for using real-time video and having business meetings using it. And we thought that, okay, well, what if we built a consumer social app that used kind of audio and video and allowed you to meet people that were new on the internet? So similar idea to our location-based thing, but now using video. And so we applied to YC with that and ended up getting in. And so we went through, I think it was the 5th batch of YC, the second last batch in Boston. And that's kind of how my entrepreneurial journey started. I've gone through ebbs and flows ever since, where I start a company and then join a company and then start a company and join a company. But yeah, that was kind of like the start of it all.
It's funny, man. We have a lot in common. So I also went to high school in the Bay Area.
Oh, you did?
Spent my high school years. I also went to CES at 14. So we might be tied for the youngest, and then spent my high school years, in the summer going to hackathons and angel pitch meetings and all of that. So
no way. Where did you go to high school?
Sarah in San Mateo.
Oh, okay, right on. I went to Lynbrook in Cupertino.
Okay, yeah, not too far. That's funny. It's funny. It's a small world, and it gets smaller and smaller. I'm curious, just double clicking on Y Combinator, like what were the biggest takeaways from going through YC? You were super early, 5th batch.
Yeah, I think that if you look at how YC has evolved, you'll see that I think the companies, they definitely have some companies that are just starting off for the first time, or, it's kids out of school that are just starting. But now there's also a lot more companies that are a bit farther along in their journey. And there are some founders who are repeat founders or, have kind of seen this movie before and make better decisions. I think back then, YC was so early, it really was pretty much all just kids straight out of college that were trying to start companies. And I think the takeaway that I had, or my personal learning from YC, was what we were doing was so new. YC was new, and then what we were doing was so new, like cameras and microphones, and being able to send that data over the internet and even access it in a browser. We had to build a bunch of technology even just to make that possible at that time. And I think it was a new, exciting idea and when we were talking to like founders in the YC batch, they were really excited about what we were doing and they were giving us all these ideas. And I think for me, I was just getting pulled in all these directions. I didn't really have like a core vision of where I wanted to take what we were building. I just thought it would be a cool thing to do and that people would find it interesting if we put it out there on the internet. But I really didn't have a vision. And I allowed that vision to kind of get formed from the inputs of all these other founders who weren't thinking about that problem or weren't thinking about building something in that space as much as I was. And so I found my experience was that when I was running that company, it was just very unfocused. It felt not even like a company, to be honest. It felt kind of like we were just messing around and we were doing it within the confines of this startup accelerator. But I wouldn't even like call it like founding a company. That's my big learning is you have to have a lot more things kind of in your mind set strategically, and like the vision for the company and where you're going and why are you on this mission. Like you have to figure out what your why is as well, before you go and do something like starting a company. And I didn't have any of those ducks in a row when I was doing my first one.
Yeah, I think that's a shared experience for most founders. And now starting to talk about LiveKit and AI.
Yeah.
What was the founding thesis for LiveKit?
Yeah, it's interesting because when I think about like what my YC company was doing, my friend, a good friend of mine, he always told me that we kind of have a way of coming back to the same problem over and over and over. I wouldn't say the problem that I've been always trying to solve is necessarily audio and video on the internet or anything like that. But even since I was a kid, the thing that I've been most obsessed with computers is the ability to network them, to be able to create like multiplayer experiences where you can, be with other people on the internet together, right? The same way that you can almost be with another person in a physical space together. And so that's kind of been the unifying thread throughout my life. And in YC, 15 years ago, I was trying to work on a company that was trying to connect people, instantly using the camera and the microphone. And when I started LiveKit, it's almost like, you fast forward like 13 years or something like that. When we started in 2021, a lot of the kind of infrastructure problems had still not been solved. I think because real-time audio and video was really only used for one thing primarily over the last decade, and that was video conferencing. It's having meetings. It's almost like what we're doing right now. That's what real-time audio and video has been used for. It's a single kind of use case, infrastructure or technology. And then what I think happened was the pandemic hit, and in the light of the pandemic, like everybody started to scramble to try to figure out, okay, I can't connect people in the physical world anymore. How do I bring all of these things that we do in the real world onto the internet and try to approximate them as closely as we possibly can in fidelity? And that's where the camera and the microphone come in, and the different ways that you might want to weave those sensors into your application experience. And so for me, I was building a side project actually at the time that needed real-time audio and video. And I used Agora, which has been in the space for a long time. It was powering Clubhouse in the early days. And it was through working with, using Agora as a developer that I kind of saw a lot of the shortcomings in the DevX. And then that was something that I kind of filed away in my mind as I was working on the side project. And then I had a bunch of friends who were also building things that needed real-time audio and video. And they were telling me about other shortcomings. They're using Agora or they were using Twilio, et cetera. And I started to look at the open source space because I'm like, okay, well, there are these commercial providers and they have these weaknesses. Like what is out there in open source that maybe you could use and customize and get around some of these limitations? And that's where I saw that there was nothing in open source. And I think primarily because real-time audio and video has been this niche kind of use case or need for that technology. And because it isn't commodity, open source usually comes in whenever a technology becomes a commodity need for a developer. There's always at least one that comes in and kind of takes the whole space. And it hadn't happened for real-time communication. And so I pinged my old co-founder from my previous company and I said, hey, do you want to help me work on like an open source stack so I can use it for my side project, but also have some of our friends use it who want, something a bit better than what was out there? And so we started to work on this open source stack. And I think the realization of when it turned into a company came about a year later, where when we launched open source, it just immediately blew up. And it was, for 6 months, it was a top 10 repo across all of GitHub. And we had companies like Twitter and Reddit and Spotify and Oracle who were pinging us and saying, hey, we're deploying this like internally and playing around with it. And I was like, well, why are they playing around with this a stack that only 3 people have worked on, and it just came out like a week ago on GitHub. And so that's when we started to have conversations, and we started to learn a lot more about what those companies' needs were, and started to think a lot more about where the space was going. We had a lot of robotics projects that were actually using us in those early days. Skydio almost immediately took it and started to build an entire drone teleops system for police precincts using the tech. So they have a command center, this big grid of all these cameras, like camera feeds from the drones, and you can like command and control them over like a WebRTC data channel and fly it around. So just a really amazing thing that Skydio went and built almost out of the gate when we launched open source. And that was when we said, okay, you know what? Like, there's probably going to be a lot more robots in the world in the future. Every one of those robots is going to have cameras and microphones on them. You're going to need to be able to teleoperate that robot. There's probably going to be a lot more real-time computing and multiplayer computing and synchronous computing than there's going to be, slower and async and not real-time computing. And so I think like just the kind of overall trends, we saw that there was going to be a need for an open source kind of Postgres of real-time communication that any developer could use and integrate into their app and do it for free. But some of these big companies, they actually wanted to not deploy it themselves, not scale it themselves. They wanted to have a cloud-hosted solution. So almost like textbook commercial open source path. We said, okay, well, our cloud solution is going to work a little bit differently, but it's still going to use the same stack underneath. And we're going to roll it out for some of these larger customers, or even, small and mid-sized teams that have raised venture and like are actually going to production and trying to get to scale or find product market fit. There's going to be a really convenient way for them to do that without having to mess about with the infrastructure itself and have a DevOps team to operate it. And so that's kind of how we rolled out commercial. And then, of course, we haven't talked about the AI part of this, but as much as I'd like to say that I knew that the AI part was going to be, the future, and that's what we were building towards, I really didn't. What happened at the end of 2022 was GPT-3 came out. And when I played with it, I was like, wow, it responds like a human being. I mean, I played with GPT-2 maybe a year before, and it was so crappy. Yeah. And so when GPT-3 came out and I started playing with it, I'm like, wow, this is like legit. And I said, well, you know what? Like, if you could take a speech to text and stream all those tokens and like actually pump them into GPT-3, and then what came out, you convert that to speech on the fly. If you do it fast enough and use WebRTC for that whole thing of streaming back and forth, because it's built for that kind of, workflow, then you could create a very human-like conversation with an AI model. So I built this demo. I called it Kit after like Knight Rider Kit and a play off LiveKit, of course. And I put it out there in like March of 2023, and it actually didn't get a lot of love. I don't know how to Twitter, I don't know how to tweet or how to X, even though I worked there, for 3 years in the early days. I never learned how to have tweets that perform well. But a few months later, OpenAI actually found that demo, and they had been looking at building voice mode for a while. And they decided to experiment with LiveKit and give it a try. And then they became fans of the platform. And we've been working closely with them kind of ever since on voice mode itself and all the new stuff too. And it was in that moment that we started to work with OpenAI where I realized how LiveKit can actually play a huge role in the future of kind of this AI movement, or AI computing is what I have started to call it. And that is, if a company like OpenAI or Anthropic or Gemini, et cetera, the foundational model companies, if the goal is to build AGI, what is AGI? It's a human-like computer, or it's a synthetic human or a silicon human or something like that, right? Whatever metaphor you want to use. If that's ultimately the goal, how will you likely interact with that human-like computer? You'll probably use native human APIs or inputs. You and I are using our eyes and our ears and our mouth primarily to communicate. Well, the eyes of a computer is a camera, and the ears of a computer is a microphone, and the mouth of a computer is a speaker. And so LiveKit really builds infrastructure that allows you to wire up any piece of software to a camera, a microphone, and a speaker, and is the transport layer from those sensors on a user's device to an AI model, and then back out from the AI model over LiveKit's network to back to that device, and it's played through the device. And so I think that the future of AI is going to be multimodal. And if you have that brain, you need a nervous system to carry the signals to and from that brain. And that's kind of where I see LiveKit fitting in, is we are really building that transport delivery layer for multimodal AI wired up to one of these foundational model brains.
That's a very helpful overview. Maybe we can dissect that a little bit. It's interesting. So at ARC, we were large investors in Zoom, through the pandemic. And, talking to Eric and some of the engineering leaders there, like they always pressed on the fact that having like real-time audio and video that works reliably, across the globe is an incredibly hard engineering problem. And I'm curious from your perspective, like what is so hard about that? And obviously you guys are solving that problem yourselves, but what is like the hard part about that?
So I think what's interesting is the hardest part about real-time audio and video, and for something like Zoom. So I have so much respect for Zoom just because they've spent over 10 years working on this problem. Zoom has this reputation in that it always works, and it honestly does always work. There is no infrastructure except LiveKit. We're aiming to get there. I'm not going to say that we're at Zoom level reliability yet, but we're probably the most reliable infrastructure outside of Zoom. I'd say we're getting quite close, and having something that works reliably everywhere in the world with a high quality of service, no matter where you connect from in the world, that's a very, very hard problem to solve. But what's interesting about it is it's not actually a hard problem to solve from an audio and video perspective. The right codecs or encodings or compression for audio and video, that's already there. It's already open. Opus is out there, AV1, VP9, these types of codecs are already available and out there, and amazing work by the people who have worked on those. The hard part about delivering 5 nines of uptime, reliable, high quality audio and video, it's actually more of a distributed systems and networking problem to solve, not a kind of audio and video problem to solve. WebRTC is also an open protocol from Google that is responsible for doing a lot of the heavy lifting around the media itself. But WebRTC was designed to be a peer-to-peer protocol. It wasn't designed to be a protocol that have even 100 people in a session together that are communicating with one another. Because it's a peer-to-peer protocol, it doesn't really scale beyond like 2 or 3 people. And that's because when you use a peer-to-peer protocol like WebRTC, every single person in that session is sending their media to every other peer in that session. So when you have a session with 4 people, I'm sending 3 copies of my video, 720, 1080p, whatever it is, to 3 people at the same time over my home internet connection. It's just not going to happen if you try to add a 5th person to that. And so there's an obvious scaling bottleneck at a very, very low amount of scale for a peer-to-peer model like WebRTC or vanilla WebRTC. What people do is they put a server in the middle that acts like a WebRTC peer, and everyone just sends their media to that server. And then the server is responsible for routing the streams back down to whoever needs to receive those streams. That's kind of the first unlock for scale, but there's limitations there too. Where is that server hosted? If that server is hosted in the UK and I'm connecting from San Francisco and you're connecting from Japan, we're all sending our streams to the UK, right? Which is not the most efficient path for latency to route your video. And then if that server goes down, well, then how do you resume a session? So there's a reliability issue. That server is going to crash at some point. And then, of course, there's scale. So you can vertically scale that machine, get a more and more powerful box in a data center. But what happens when you run out of resources on that physical machine? How do you actually split sessions across multiple machines and do load balancing? not an easy problem to solve. So then there's a next level of scale. And this is what Zoom has built internally and what LiveKit Cloud, our commercial offering, provides as well, which is you need to be able to deploy multiple of these servers all around the world, allow every user to connect at the edge, and then all of their streams are forwarded in kind of a mesh coordinated system between all the other servers and then back down from the server to whoever needs to receive it. And so you have this kind of network fabric on the back end that is going over the private internet backbone. And then within kind of that network fabric, there are networking and routing issues you have to deal with. So how do you load balance? How do you spin up new machines as you get load coming in? What happens when maybe you're hosting a live stream and you have thousands of users joining at the same time? How do you deal with like a stampede of users and spinning up resources, having a pool available so that you can kind of service all of these connections? What happens when you have a cloud provider go down or a node crashes? How do you migrate people over to another server transparently? What happens when there are connectivity issues between two servers in two different regions? Because sometimes, for example, most recently, there's been a damage to undersea cables that go to Asian data centers. And so a lot of people who are trying to connect in that region have issues connecting because there's a bottleneck on kind of the transport layer underneath, like the physical cables under the ocean. So how do you route around those issues, or what do you do? And how do you build an entire software-defined routing layer that can, effectively, we can program a system that is measuring the network in real time, routing around those issues, creating redundant pathways for fetching the media. So there's all kinds of challenges involved with these problems. The reason why it's taken Zoom so long to do it and why it's a very hard problem on top of all the stuff that I just described is the internet is like the road system. And sometimes, you're on 880 during rush hour. Those roads get clogged, or sometimes you're going over a small residential street, or you're crossing a bridge and there might be like a deer in the middle of the road. It's like there's so many unknown unknowns that you have to figure out how to deal with when they happen. And so there's a bit of a chicken egg, is that if you want to deliver high quality of service, something that works every time for every person on the planet, you have to actually have traffic going over those roads, those internet roads, so that you can figure out, oh, okay, what do I do when there's a missing section of the road and I need to, I don't have software that deals with that yet. I haven't figured that part out. Okay, I need to go I need to go patch my routing system to figure out how to deal with that. And so there are all these different issues. It's very fragmented that you have to solve. And the only way to solve them is to actually try, to have users exercising those paths to show you where the issues are so that you can go and write software to mitigate those issues. So it's really hard.
Makes a ton of sense. And my next question, which I think you implicitly answered, is like the buy versus build question. I would imagine if you're a company that needs this technology, as soon as you deeply understand the complexity, it probably makes more sense to go to LiveKit or another provider that is abstracting away all of that complexity.
For sure. With LiveKit open source, one thing that we had to do to build a sustainable business, to continue to work on open source for the next decade or two, is we need to figure out, when we commercialize, where do we draw the line between commercialization, right? The buy versus build kind of decision that teams are going to make. You can take LiveKit open source and you can build, right? And a lot of the technology is available to you there for free. But why do you want to buy from LiveKit versus just using LiveKit open source to build? And so we had to figure out what is the right place to draw that cleaving point between what is paid and closed and proprietary and what is free. And the place that we drew that line was deployment and scale. So if you're building something that is fairly low scale, or that is running in a single country, you can use a single server to kind of service your users in your product. They don't have to go, they're not connecting with anybody across the world or outside of the country that they live in or in the region that they're in. Then you can use LiveKit open source, and it's fairly easy to spin it up. And a lot of the operation of it and auto scaling of those single servers instances is done for you in LiveKit open source. And so it's a strong product for that. But I think once you get to a level of scale, where you have to have the 4 to 5 nines of uptime. You have users that are connecting all around the world. You need them to all connect with the lowest latency possible. You don't even want to think about how to scale and how to spin up new servers and load balance between them. When you want all of that, that's when you should use LiveKit Cloud. And so I think for a lot of folks that use LiveKit, they start using LiveKit open source and they build their product in, locally or in staging using LiveKit open source. And then when it's time to go to production, they just change an API key and a secret. So one thing that we deliberately did in this kind of buy versus build decision is we built all of our orchestration for our cloud product using the same core open source server underneath. And so we built the right hooks into the open source server. So if someone wants to go and try to build their own orchestration system, they can do that. It's going to take some time to do that. It's taken us, years, and we created the server as well ourselves. But by using the same open source server, all the APIs and SDKs are exactly the same. So when you switch to LiveKit Cloud, you don't have to change a single line of your application code. You just go sign up for an account, create a key and a secret, plug those into your config file, and then now you're running on cloud instead of running on your own deployment or your self-hosted LiveKit stack. So it's pretty frictionless to be able to go from just like build initially to buy later when it's time to go to production.
Do most of your customers start with open source and then move up to the hosted version? Or do you have a lot of customers coming to you and starting with the hosted version given they're already large companies?
I would say probably maybe a good 75% actually just go straight to cloud. I think that definitely some use open source, and there are certain use cases like where you have strict compliance or security policies. There are a few companies that use LiveKit that have to deploy they deploy software in like the biggest banks, the data centers for banks all around the world, and banks are really, strict on their security policies. And so LiveKit Cloud is just not going to work for those folks. And so they go and deploy open source. There are other companies that want to have full control over the stack. And so they use LiveKit open source, but other ones even actually we have another SKU called LiveKit Private Cloud, which is our LiveKit Cloud. Everything that we do, all the tooling, the analytics and operational software for LiveKit Cloud, plus the mesh network orchestration, we package that up and we actually will license that out to certain companies. So there are certain companies that need the scale, they need the edge latency and all of that, but they also want to be able to run it in their own VPC. And so there are, for example, there's like a rocket company that does this, and they're in a highly regulated environment, and so they need to do this on-prem. And so we license them cloud. But I think between these three choices, the vast majority just use cloud because it's the fastest way to get started, fastest way to find product market fit and scale.
And when you look at like the infrastructure stack broadly for AI, I think most people think compute right off the gate, right? Like you've seen that with NVIDIA. Networking, as you're tackling, is also a big problem set. What other problems do you see in the infrastructure stack that are challenging or unsolved?
Yeah, it's a good question. There's a lot of stuff, and I think it's changing so rapidly. That's also a really challenging thing about kind of building infrastructure for AI in general, is that the ground is shifting so quickly underneath. There was a demo today of this full multimodal model that's only 7 billion parameters from this company called Qtai. I'm not sure if I'm pronouncing that correctly, but it's 8 people and they built their own LLM, and it can take audio in, respond with audio in like 200 milliseconds. It's insanely fast. I'm excited to have an integration in LiveKit as well, so you can use that with WebRTC. For us as the transport to that model. It's an example of just how quickly things are moving. And from the infrastructure perspective, I think, of course, network is something that not a lot of people have been focused on, but I think is now getting some more focus with these kind of audio and video-based models, these full multimodal models. And then on the other side, of course, the LLM is like a key part of the infrastructure. But then around that, there's a lot of stuff too. So I've been asked by quite a few founders lately, people that are using LiveKit, about evaluation. How do I actually figure out that when I build a model, especially a voice model that's getting on the phone and, for example, here, taking calls from a hospital to do patient intake, how do I actually verify that this model is able to have a conversation with the patient that's calling in and asking the right questions and collecting the right information and being efficient about it? And so what that company ended up doing, because of just a lack of the tooling there, is they built another assistant that calls in and pretends to be the patient. And they have a conversation, two AI models have a conversation with each other, and then they kind of like listen to that conversation and look at the transcript of that conversation to see, okay, does it sound human? Is it actually asking the right questions and all of that stuff? And so I think evaluation is a really interesting one that people have been asking for a lot. I'm trying to think of some other ones too. Another one that is interesting is maybe a little bit more basic, is just transcription. When you're talking to a model using your voice, like oftentimes you still want to have a transcript that shows up, or some captioning that shows up, so you can kind of fully grasp what the model is saying if it doesn't pronounce something correctly. If you're speaking with an accent, I think that there's all kinds of considerations for why you want transcription. But there are a lot of kind of opportunities, in my opinion, around building the right infrastructure for the space. I talked to a friend of mine actually who's building an AI model for a recruiter. He's building an AI recruiter. And something that he told me that I thought was interesting is that we're trying to put a lot of pressure on the LLM to be able to do everything and be able to give it very complex instructions that it can parse through and figure out on its own. But the models are actually good enough now, especially with the function calling, you can get the function calling to be reliable enough that if you piece together your prompts such that they are small enough that the model can tackle it with a high degree of precision or accuracy or reliability, call it, you can write software that orchestrates how that model actually goes through a flow. So I think LangChain is in this space and does stuff here on the infrastructure side, and there are some other companies too. But you can get AI to do very complex things if you have a solid software layer that interacts with call it the inference layer. And the software layer it's deterministic. You don't have to use the LLM for it. Like, we know exactly what that workflow is. And so you can write code that kind of, deterministically goes through that flow and does the right things at the right time. So that's another area of infrastructure that I think is going to be increasingly important as we have the LLM butting against the limitations of what it's able to do on its way towards becoming more and more human-like. It's going to take some time, I think, to get the LLM to be 100%, as good as a human at everything. And in that gap of time, orchestration and software is going to fill out that missing piece, or that chasm between the two.
100% agree. Yeah, that's a great take. If we switch to multimodal AI and what the future is going to look like, most people's interactions with AI up to this point have been through ChatGPT, where you're just interacting through text. And obviously we're starting to see some of these multimodal models that are really impressive. One of the things that I've been thinking through is like the form factor. So once you have audio as a modality that you can use to interact with these very powerful models, what is the form factor going to be? Am I just going to talk into my phone like I would with Siri? Or is there going to be some new form factor that takes hold?
Yeah, it's a great question. I actually just saw a tweet this morning that I responded to from Logan Kilpatrick, who was the head of DevRel at OpenAI, and then now is on the Gemini team heading up DevRel. And it's interesting to think about what the form factor is. For me, a lot of these questions kind of about where AI is going, or where I think AI is going, I like to kind of draw an analogy to human beings, because that's kind of ultimately what, in my opinion, the end state is we're tool builders as humans, and we are building the ultimate tool. The ultimate tool is ourselves. And so I like to draw an analogy to what do human beings do? And for me, that kind of paints a picture of what will AI ultimately do? How will we ultimately interact with it? I've been saying kind of now in blog posts from LiveKit and stuff like that the camera and the microphone, I believe, will eventually replace the keyboard and the mouse. I still stand by that statement. I think that as AI gets smarter and smarter and more capable, it's going to communicate with you the way that a human communicates with you naturally, right? I talk to humans. I ask them to do things for me. I ask them what their thoughts or opinions on things. I ask them if they've heard about X or if they know about something that I don't know about. So I think what we'll see is we'll see a lot more audio and video. And when I say video, I don't necessarily mean video synthesis. I think there will be video synthesis for sure, AI generating videos for you. But I think that that's going to be more of like an entertainment use case. This is just my guess. I think it's going to be more about AI generating content for you that you can consume in a lean back kind of entertainment use case, where I think video is going to be much more used by AI is as an eye, as computer vision. That there is something that is unlocked when a computer or even a human being can see you. We are visual creatures. We get a lot of information that just come from unspoken cues using our eyes. And so I think adding vision to multimodal AI is going to unlock a lot more capability and make the AI a lot more impressive in its understanding of us and how we're trying to interact with it. But I think vision and voice together are going to become most likely the dominant form of how you interact with AI and computers. You will still text. There are still scenarios in the world where you text. I text my friends all the time. I post messages in Slack all the time. So I don't think we're going to stop using our thumbs or texting in some way. But I do think there's going to be a lot more video and voice, and that's going to become the dominant form. And then I think there will be two consumption paths for AI in terms of the form factor. The first form factor is going to be some kind of human augmentation. So we're either going to be wearing a computer on our chest. I don't think that that's necessarily going to be the ultimate form factor, probably in front of our eyes, in our ears, maybe, a brain implant one day. I don't know. I'm not going to be the first one in line for it, but there will be some kind of augmentation of computers on our body where when we walk around, we have our Cortana with us, and that Cortana is able to see the world as we see it, perceive it as we hear the world, as we're walking around, and being able to help us as we navigate the world. I think that's one form factor. And then the second form factor is going to be humanoid robots. There's this increasing pressure that as AI models get smarter and smarter, as that brain develops and gets better and better, you need to embody that brain. And so there's companies like Tesla, of course, and Figure, and there's other ones as well that are building kind of these early humanoid robots. But I think there's going to be a lot more of those walking around. And the way that you interact with a humanoid robot is the way that you interact with a human being, which is to just talk to it, ask it to do stuff for you, ask it to do the dishes and to help you. In my opinion, I think that the consumer device or the augmented, the AI that lives inside your Mac or your phone, et cetera, I think that's going to be used a lot for work, for, having an AI help you take on these agentic tasks, go and, onboard this new teammate that I have in Gusto or whatever it is, right? I think there's going to be a lot of workflows that happen from AI inside of your devices. And then I think a lot of personal kind of consumer-oriented flows are going to happen with robots. Because if I think about like in my personal life, the work that I have to do in my personal life is doing the dishes and getting groceries and stuff like that. Those are the things that I want some kind of AI or machine to just go and do for me. And I'm going to sit back and I'm going to play a video game, or I'm going to have a conversation with my friends, or I'm going to, watch TV or whatever it is. And so I think like what AI will help us do is it will help us automate tasks or work that we don't really want to be doing. And so, yeah, that's what I think the split is going to be. I think it's humanoid robots on the consumer side, and it's, AI embedded in our devices when we're working.
Makes a ton of sense. I completely agree. Have you tried the Vision Pro headset?
Yeah, I have a Vision Pro. It's like an alien artifact in terms of the technology. It's one of those things where when you use it, it's not it. Like that version of it is not it, but you also can see it. Like you can see where it's going to go. And I am like very bullish that, I don't know what it's going to be, version 5 or something like that of the Vision Pro is just going to be like flat out amazing. I think what the Vision Pro has done is it has, in my opinion, convinced us that AR, VR, metaverse will one day happen, 100% guaranteed in my mind. I just don't know when that day will be, but it will definitely happen. If you spend any time with the Vision Pro, you will be convinced of that.
I agree. I've been bearish on AR, VR for forever until I tried the Vision Pro. I was like, okay, now I understand. But to your point, like, you don't have a keyboard, but just the way you interact with it with your eyes alone just feels so natural and intuitive.
Totally.
It's really impressive.
Yeah, I don't know if you've ever, I'm sure you've tried to type on that thing. It's horrendous.
It's useless.
Anytime I need to like one password in, like it's just, it's the absolute worst. But yeah, the thing that Apple nailed is they really nailed the hand tracking and eye tracking. It's just, it feels so perfect. It's astounding to me.
100% agree. And we're coming up on time, but a couple of quick questions. So what are the coolest multimodal use cases you've seen?
I mean, for sure, I think, it's the one that everyone's seen. I think GPT-4o, that demo was just something else. I think like when you get the latency that low, when the voice is that convincingly human, you can see where computing is going to go. It feels so natural to interact with it. I talk to a lot of friends about how their kids interact with computers, and they tell me, oh, my kids leave voice messages with their friends and they interact with Alexa and Siri all the time. And, it's just such a natural interface, like using the iPhone for the first time, and like the tactile feedback you get from interacting with a touch screen or a touch device. That's kind of what is unlocked when you get the latency that low for multimodal. And so I think the GPT-4o demo was this kind of amazing moment. In my opinion, I put this on our About page, but I felt like when I saw that demo, it was 40 years, to the year after Steve Jobs was on stage at De Anza College, demoing the Mac to the world for the first time.
Wow.
And the Mac said, hello, I am Macintosh. And the crowd just cheers. And it's like, wow, like we have a computer that can talk to us. And I think that's been the dream of sci-fi from the very, early stages of it. People have been talking about this forever. And 40 years later, 1984, now 2024, this GPT-4o demo, in my opinion, was like the starting gun for that future we've been dreaming about for a very, very long time. So just so excited. I don't think I've seen something as amazing as that since probably like maybe the first Oculus DK1 or maybe like the iPhone even. I think it was an incredible moment.
LiveKit's enabling it. So it's going to be a good decade.
It was an even more amazing thing to be part of that too. I felt like I was doing something to contribute towards the future of how we're going to interact with computers. And so, I think regardless of what even happens to the company, I'll never forget that moment. It was really special, really special.
It's incredible. If I'm a developer somewhere that wants to use LiveKit, or someone who wants to work at LiveKit, where would I go?
Yeah, few different places. I think, livekit.io is a great place to start. You can go to our GitHub as well, github.com/livekit. And that kind of introduces you to the whole ecosystem of repos and things that we have for you. And then, of course, you can DM me anytime on Twitter. I'm fortunate that I worked at Twitter early, so I have a short username. It's @DSA, D for David, S for Sugar, A for Apple. Hit me up on Twitter if you need help working with LiveKit, if you have any questions, or even if you want to work at LiveKit. Yeah, hit me up anytime. I'm happy to have a conversation.
Awesome. Well, Russ, thanks for joining.
Thank you so much, Will. It was a lot of fun.
Thanks for tuning in to the Autopilot podcast. If you're using AI to create or disrupt a large industry, I would love to learn more about your story. Drop me a line on Twitter or go to our website, apv.vc. If you want to support the show, the best ways are to leave a review wherever you're listening and subscribe. The Autopilot podcast is part of Turpentine, the podcast network behind Moment of Zen, Turpentine VC, Age of Miracles, and more shows for experts by experts in tech.